All right, so again, some things to keep in mind when solving our trig equations here in our second part of 4.2. We saw things where if it's linear or quadratic, use the appropriate method to solve. If you only have one trig function, then just get that isolated by itself and solve. If you have more than one trig function present, we want to rearrange it so you have 0 on one side of the equal sign, so you can use the zero product rule. So we're going to factor it, and hopefully one of those trig functions isn't a factor by itself as well as the other. If the equation is quadratic but not factorable, you can use a quadratic formula or complete the square like we did in the previous video. And sometimes you may have to square both sides. When that happens, you definitely want to check for extraneous solutions. It's always good to check things out. All right, extra practice here. I'm thinking I need my Pythagorean identity. I'm going to take and I'm going to isolate the cosine squared x in my identity, change it to 1 minus sine squared x. I just like sines better. Plug that in, combine like terms, and now get sine squared x by itself. Subtract over the 1, divide over the negative 2, we get a positive 1/2. Now I got to take the square root of both sides. That gives me plus or minus 1 over the square root of 2, or that's equal to plus or minus square root of 2 over 2. So I'm thinking 45-degree reference angle, but because it's plus or minus, I'll have an angle in every single quadrant. So 45 in quadrant 1, 45 in quadrant 2, 45 in quadrant 3, 45 in quadrant 4, which gives me x equals 45 degrees, 135, 225, and 315. Now, just as a side note here, if this was not in our interval and they said they wanted all solutions, keep in mind that you can start with 45 degrees and then you just add 90 each and every time to get these answers. So you could write it as just x equals 45 degrees plus 90n. And that way you don't have to do 45 plus 360, 135 plus 360, 225 plus 360, 315 plus 360. We can get them all wrapped up in one neat package. 45 degrees plus 90n. Okay, next example. Ooh, whoa, time out. Tangent theta minus cotangent theta equals 0. Oh boy. Okay, so we don't want to add the cotangent theta over to the other side. This would be like saying x minus y equals 0, and you get x equals y, and okay, x equals y, y equals x. That we can't solve one variable in terms of the other here. So because it's set equal to 0, what I need to do is I need to do some factoring. Factor one of these two trig functions out. It doesn't matter. I'm going to go with cotangent. Now, I know what you're thinking. There's no cotangent factor here. That's okay. Think about when you factor something out. You divide each term by cotangent theta. And that's factoring the cotangent theta out in front. So that's going to turn this term into a 1. And then I'm going to write this as cotangent theta times 1 over cotangent theta. Just like that. And then realize, hey, wait a minute. 1 over cotangent theta as a reciprocal identity is tangent theta. And so now this becomes tangent squared theta. But here's my cotangent in a factor by itself. Here's my tangent in a factor by itself. We'll set them both equal to 0. And now we'll go solve. So cotangent theta, let's see, when is that equal to 0? That's going to be cosine over sine. So I need cosine to be 0. And I need sine to be a 1. So let's see. That would be at pi over 2, 90 degrees, and 270, or pi over 2 and 3 pi over 2. Tangent squared theta, well, minus 1, add the 1 over, take the square root of both sides, that's plus or minus 1. So we're looking at a reference angle in all 4 quadrants, and tangent theta equaling 1, that's a 45-degree reference angle. So very similar to the previous problem where we had 45 degrees, or in this case pi over 4, 135, which is 3 pi over 4, 225 degrees is 5 pi over 4, and 315 degrees, 7 pi over 4. So here's my 6 answers. But again, we want to calculator check this. So if I go to my calculator, I'm going to type in tangent of x minus, I'm going to put cotangent in as cosine x over sine x, like I said earlier when we were finding these answers. And then I'm going to graph it. And I put this one in radians. You can also leave it in degrees if you want. So holy cow, lots of crossings going on here. So pi over 2, I hit the trace button, I type in pi divided by 2, that's 1.5707963. Notice there's no answer for y. There is no y-intercept. That tick mark right there is our pi over 2. There's our pi. There's our 3 pi over 2. So I don't see no tick mark being touched for this one either. Both of these answers are not any good. We have to throw them out. The graph says here's pi over 4. That's this decimal in radians. And then you can check 3 pi over 4 would be this next mark, because again, that's pi over 2, pi, 3 pi over 2, 2 pi. So we're cutting each one of those in half. So it appears that all those work. So again, you can keep typing it in if you want to check it in your calculator. More than welcome to do that. But I can see that happening on my graph. Next, we're going to solve 3 times cosecant x minus 2/3 equals 0. So one trig function, find all exact solutions in degrees. So we're putting on our plus 360 degrees in. Isolate the cosecant x. Let's add over the 2 square root of 3. Divide over the 3. Well, let's see. We want to flip this to its reciprocal. So that's going to be sine of x equals, flip this, 3 over 2 radical 3. Rationalize it. Multiply the top and bottom by the square root of 3. Then reduce the 3 into 6 to get square root of 3 over 2. This is positive, and it's sine. We are going to have angles in quadrant 1 and 2. So square root of 3 over 2, that's my 60-degree angle. So I need a 60-degree reference angle in quadrant 2. So 180 minus 60 is 120. So there's my 2 answers from quadrant 1 and 2. We'll just go add on the 360n to each answer, and we have all of our exact solutions. And that wraps up our 4.2.